welcome back. I'm still Mr. Nyaga, your physics mentor, your physics teacher. Now, we have already verified the Archimedes principles mathematically. Now, I want us to verify this Archimedes principle experimentally. That is, the upthrust force experienced by this body is equal to the weight of the fluid displaced. So, welcome. Let's have a demonstration here to have a look at this Archimedes principle. So to start with, I have my spring balance to take the weight of some masses, and I have some mass here. So I want, as we have this, students, let's have a look. Let's see what will be the weight of these two masses. Now, student, you can see that the weight of these two masses which I have here is 2, because our spring balance has some error of 0.5. So we take the weight of these masses to be 2 newtons. That is when it is in air. So record somewhere that the mass is 2 when it is in air. Let's now take the mass of these two masses when they are immersed in a liquid. When they are immersed in a liquid. So we have our liquid here. We want to see what will be the reading of this balance. So walk with me. Have a look at this. So we expect the weight to reduce. And we can see that the weight is around 2 newtons. 2 newtons. That is when we immerse this body or this weight in water. So record that. The weight in air, we said it is 2.5, and the weight in air, weight in the liquid is 2. So let's have some calculations here. So we say weight in air, 2.5 newtons. Weight in liquid, we take it to be 2.0 newtons. Now, we can see how we can easily calculate the upthrust force experienced by this body. So the upthrust experienced by this body, we said upthrust is equal to weight in air minus weight in liquid. So weight in air, upthrust, we said it is equal to weight in air minus weight in liquid. So therefore, we'll have our upthrust as 2.5 minus 2.0, which is 0.5 newtons. Now let's continue and now look at when we immerse these bodies in water, what will be the weight of that liquid which has been displaced. So let's continue with our demonstration. Now, student, let's take the mass of this beaker from the weighing balance. So we can read it there. Let's wait, see what will be the reading. Our beaker here has a mass of 52.76. So you can record it somewhere, 52.76. So mass of empty beaker is equals to what, student? We have said 52.76 grams. Let's continue with our demonstration. Now, student, we want now to immerse these two our object in water and measure the weight or the mass of the displaced water and see whether it will be equal to the upthrust. So let's see. We immerse the liquid, the bodies in water. So we have already immersed Let's see until the volume that water stopped dropping. Let's have a look at that. So water is okay now. Let's see. The water has stopped dropping from the Eureka can. Let's now see what will be the mass of the water which has been displaced. So the mass of the beaker and the water, let's have a look and see what will be the mass. Now, student, the mass of the water plus the beaker, so let's record somewhere the mass of the water plus the beaker. This is the water which has been displaced when we add the weight or the object into the Eureka can. So the mass of the beaker, mass of the beaker plus the weight of the mass of the water displaced, mass of the water displaced, mass of the water displaced. Student, we have seen from our weighing balance, we have seen that it is 102.212 grams. So we have already done our experiment. Now we want to show that this one is equal to the weight of displaced. Okay, now students, we want to calculate the mass of the water which has been displaced. So to get the mass of the water which has been displaced, we say the mass of the beaker plus mass of the water displaced minus the mass of the empty beaker. So therefore, when you take your calculator, students take your calculator, mass of the water displaced. So we say mass of the water displaced, mass of the water displaced will be equal to mass of the beaker plus mass of the water displaced minus mass of the empty beaker. So we say 102.12 minus 52.76. So 52.7, so let me just write it somewhere. So it is 102.12 minus 52.76. So using our calculator, student, what do you get when you subtract the two? 102.12 minus 52.76. We get our mass of the water displaced to be 49.36 grams. Now, from there, we want to get what will be the mass from this, what will be the weight from that mass. From this mass, since it is in grams, let's convert this mass into kilograms. So to convert into kilograms, mass of this displaced water will be 49.36. You divide by 1,000. So when you divide by 1,000, student, you'll get 0.04936. So that is the mass, or not kilograms. But we know that weight from Form 1, we know that weight is given by M times G. M times G, where M is what? Mass, and we have G as the gravitational field strength, acceleration. So therefore, we say that weight of the water displaced will be 0.4936 times 10. So therefore, what will be the weight of the water displaced? 0.4936 newtons. And students, we can see clearly that this is equivalent to almost 0.5 newtons. This is the weight of the water displaced, and this was our upthrust force. So therefore, we have verified this Archimedes principle by saying that